Hello, everyone, and welcome to the next episode of Scala Space Podcast. Today, with me is the creator of Scala programming language, Professor Martin Odersky, computer scientist and professor at EPFL in Switzerland. Our topic for today will be the new initiative called Lean Scala, and we are going to discuss the complexity. So, Scala is a programming language that is often joined with the concept of complex code. And Lean Scala is an initiative that is targeting this preconception, this perception of the language. And it's also a thing that has been happening for some time now. I wanted to start with the historic perspective on this topic that as an engineer at Virtus Lab, I have had for like last 4 or 5 years. A few years back, around the early COVID times, so 2020 probably, we had an internal discussion among the engineers at Virtus Lab that Scala is dangerously drifting towards being placed in niches. So we had Spark, and we had Spark in the niche of big data processing. So Scala was placed in this big data niche. There was Scala that was being used in a purely functional front, and this was at the time a growing community of Scala. So also a niche of the overall programming community. There was a lot of complexity related to building of Scala programs, and one of the conclusions of this discussion that we had internally was that we would like to propose some possible initiatives, changes that could make Scala more inclusive to beginners, to new programmers, to make it easier to onboard onto the language. And coming out of that were both Scala Toolkit and Scala CLI. In the current year, so 23, Martin did propose something new on, I think it was Scala, right? Where he had this talk about Lean Scala. And he also wrote a blog post about it. So I would like to ask you to explain your understanding. Our understanding was that we wanted to simplify how the language is used, both on the coding front and on the working front, so tooling front. What did you mean when you wrote the blog post about Lean Scala? What does Lean Scala mean for you?
So, Lean Scala simply means that we want to emphasize simplicity. So, programming languages are a bit of a double-edged sword because essentially we use high-level languages to express ourselves clearly and simply. But the same tooling, the same mechanisms in the language also let us build abstract things and compose our own things, give us almost unlimited freedom. And that is sometimes the right thing, and sometimes it's not. And the Lean Scala means knowing the difference and avoiding the traps and pitfalls of needless abstraction, over abstraction, needless complexity. So it's more a sort of an appel to reason than anything that is clearly defined in terms of feature set or things like that.
So, in your perspective, is what kind of approach is this? Is this like library level approach, or is this an approach on the tooling front? Where do you think there has to be, more pressure to write in the Lean style of Scala?
But I think tooling, of course, everybody wants simple, straightforward tooling. And it's true that has been lacking or lagging behind in Scala for some time. And I think it's really good to see Scala CLI with shipping with 3.5. And I think Scala Toolkit is also a very interesting proposal, even though it's still quite in its infancy. The other thing, the thing that I saw is sort of more in my corner of the court is the language design. That means really the notation with which we express ourselves. With tooling, I have to rely on basically others to help, and I'm really overjoyed that this is happening. But I'm from my perspective, it's more the language design, and there it's sort of indirect. It's as I said, we design the language so that libraries can be constructed. So which libraries are constructed, and do we find that that is the right way to go about? By and large, it is, but I mean, not always. Scala has a label of complexity for some reason, and I think we have to really look hard at why it is regarded as complex, and how we can change that. Not only the perception, but also the substance. But as a language design, from a language feature point, it's sort of an indirect thing, because I think about the features to put in the language that then libraries use to present their abstraction to the user. So there's an intermediate layer.
Okay, I wanted to ask about a concept that you mentioned in your blog post, and it's something that seems to be in a contrast. There is a different point of view, which is quite often voiced in the Scala community, and that's the principle of or rule of least power. So I've encountered this idea mentioned multiple times by prominent pure functional Scala community members, could dress it up as, you should write your code in a way that limits the amounts of things that can happen in a function, which basically boils down to making functions polymorphic and just declaring all the possible things that this function might use as constraints on those generic types. So
Yeah.
you did mention that your point of view is inspired by the blog by Ahoy Lee,
Mm.
and I wanted to ask how you understand the rule of least power. How do you envision enforcing or using that in programming practice?
Well, it can have many meanings. I'm really referring to the blog by Hao Yi, who I think first coined that phrase in the Scala context. So his definition of least power was that use to express something, you should use the least amount of concepts and flexibility to get there. So his example was, if something can be a static method or an object member, then make it that. Don't invent a class that you have to instantiate, or that can be multiply instantiated for that. So you take away a freedom, namely to have multiple instances. And if something is always the same type, then make it that type rather than making it polymorphic. There is an interesting take on it in the purely functional camp, which comes from from parametricity, to say one way to constrain power is by making things more polymorphic, which is true. But that was definitely not what Hao Yi had in mind. So it's almost the opposite of what he had in mind, I'm sure. So the way I reconcile these two things is that using parametricity, you have to rely on something which is essentially a framework, a thing that sets the rules, that gives you the parameters that then application code needs to instantiate. And if you want to do that, then you have to learn a rather big concept first, and that's the framework. So there are many tasks that essentially you can use the principle of least power that will not require the framework, so you should not adopt it unless there's a need to. If you do adopt the framework, then these frameworks, the way they use the theory for parametricity is actually quite clever and very useful. But adopting the framework is the first big step, which tends to add a lot of complexity. So I'm not saying there's no reason to do that, but there are situations where this complexity is maybe not necessary.
Okay, so you do mention that for you this rule means using the least amount of concepts. By concepts, I understand that you mean possible Scala features and interactions between them, right?
Yeah.
Is there something like a catalog Like, it's something that I was thinking about for ages now, that we probably should have something like a guidebook. Like, okay, those features are, very simple. You can use them wherever. And those features, well, dragons beware. So, is there something like that? Do you keep something like that in your head? How do you discern between features which are advanced and which are basic?
So there was at some point a long time ago, there was a list of features like that. Maybe I can just pull it up. Let me just do this. Um, so that's an old Scala blog, Scala Levels Beginner to Expert. So that was written in 2011 when Scala was very, very young, and the the scary thing at the time was all these fancy functional language features where basically the base of programmers we wanted to appeal to were typically people who were writing Java or Ruby or PHP, so that sort of background. And we said, well, it's actually not that scary because there are many different levels, and there are library levels and application levels. And as an application programmer, you just use the library things, and you don't really need to know that much. In retrospect, it's almost funny to see what things we had. So in the first level A1 was closures, okay, map filter, stuff like that, for expressions, okay. Level A2 was pattern matching, traits, recursion. And level A3 was methods like folds, streams, actors, and combinator parsing, which is quite a mixed bag. And in the library levels, it was the same. It was the same progression. For the expert library designers, we had early initializers, which don't exist anymore in Scala 3, abstract types, implicit definitions, which have been superseded by givens and higher kinded types. I think it would make sense to make a similar distinction, similar stratification with Scala 3, with today's features. We haven't done that yet, but I think it might be good to come back to it. And I'm sure that a lot of the things would be quite a bit higher than then, because at the time, really, people were just beginning with even the basics of functional programming, and we now all take that for granted. That's really common knowledge that we would assume on level 1. That said, I think it's always the underlying thing is always to strike a balance, because every feature can be misused. I give you an example. You could say, well, implicit parameters using clauses are an advanced feature, so maybe your code shouldn't use this. But if without implicit parameters, all your functions take a dozen parameters or more, and you have to pass them mindlessly through your programs, then maybe that's not such a good idea. So you should say, well, essentially, definitely don't make a parameter implicit unless you have to, but also recognize the use cases where it would help you simplify your code and apply it then. So, but I guess to say, well, if you're just starting out, it's better to stay away from them. That's probably good advice. Yeah.
Okay. I think you're right about the fact that the common understanding of functional programming and the prominence um, is indeed changed. I think a lot of people are now quite familiar with concepts like, I've seen that faults were basically an advanced feature. I don't think
Mm-hmm.
you could actually live without them currently. And given that languages like JavaScript did make them more popular because they have reduced basically, um, I think it wouldn't be in the expert application level today.
Well, it depends. So if it's just a simple fold and reduce, yes, fine. On the other hand, for instance, if once you have 2 or 3 quantities that change in your reduce, then one style would be do it purely functional, just thread this through your fold and reduce. And my response would be, well, no, just have some local vars and change them in a loop and return them afterwards. The program is just as functional as before. It just has a clearer implementation. That's all. So there are these functional acrobatics to avoid using a var that are not always appropriate, I think. And I have seen people generally go too far with that to make it almost a sport to avoid even local VARs. I mean, we all agree about global side effects and things like that, but there are essentially cases where even a simple VAR can make your code uh, simpler and easier to understand.
I think I can relate to that. I might be might be suffering from that malaise. I think I tend to write mostly purely functional code, even if it's not really entirely necessary. There's this legend in the community that, oh, it's all about the code reuse. What if you are going to use this function in a concurrent setting? Well, what if you don't? So
No, that wasn't my point at all. I said it's the same function. The fact that you implement a fold with a local var or with a essentially purely functional reducer with tuple construction, deconstruction. From the outside, it's the same function. It's just as usable in a concurrent context because every call has a different set of vars, of course. So a side effect is a side effect if it acts globally. If you have a local var, then on the outside, it can be completely hidden. And that's a distinction many people don't make. And they just stay away from vars like it was a devil's work, but which is absolutely not true. It depends on the reach of your side effects.
okay, that is true. Um, so what would you say is the um, intuition that people should have when thinking about Scala features in this context, in context of how much complexity does a feature introduce to my code? Well, I'm basically asking about a guiding principle that made you allocate those things into those level buckets.
Yeah. It's it's really difficult because, I mean, if a feature would just add complexity to your code, then I guess there would be a good reason to eliminate that feature, right? So we should have it in that case. So every feature has uh, the purpose, the motivation, and to actually simplify your code when used correctly. So the issue is mostly to get an understanding, a refined understanding, to know which features to apply when. That said, to say features that I've seen in industrial code bases sometimes shockingly overused is to pass things with implicits when there was really just no need for it. So to make all sorts of things implicits and then to essentially get burned by getting the wrong one and things like that. So for instance in the Scala compiler code base, which is 100,000 lines for the base compiler with many more 100,000 lines for the things around. There's essentially one thing that we pass implicitly everywhere, and that's called a context, and that's it. So there's no temptation to essentially dress up all sorts of other things, and of which, of course, there are many in 100,000 lines to pass them around. But on the other hand, if you wouldn't pass this context, then the code base would be a mess. So basically, do this only if you are convinced that without doing that, your code base would be a mess. If you just do it for using a cool feature, you're using it wrong. So that's one example, and there are other advanced things that I believe you should reach for only when you need them, but they can essentially do really brilliant things for your code base, but they're also hard to deal with and understand. One is match types, so type level programming in general. Another is macros. So all these things are things that are very powerful and used quite a lot in sort of advanced libraries that provide advanced services for you. But as an application programmer, you should essentially really be sure that that's the appropriate thing in your code base, because the next guy maintaining that code will have a harder time understanding what goes on.
Okay. You mentioned that you have contact with those industrial code bases, and I wanted to inquire about that because it's also a concern that I've heard multiple times voiced by members of the community, and that is, as a language designer, how do you make sure that you are you keep up with what industry actually does with the language, and um, which is more important, why they do that, what needs they
Mhm.
have that they fulfill with those advanced appliances and techniques.
Well, I'm talking with many people from industry through the advisory board of the Scala Center, where we have some users of very large Scala code bases there at Scala conferences. When I was at Lightband, it was almost daily talking to people which had some problems through the open community build, where if something goes wrong, it usually lands on my desk and I can see what happens. That's 1,500 projects. So I think I have quite a large insight in what actually goes on. Uh, and that through the open community build goes down to actual code samples, that I see what actually people write and what sort of the critical piece of code things that tend to then maybe go wrong afterwards could be. The other thing is we have a fairly large team and a large code base with the Scala tooling and compiler itself, where we essentially have developed, I think, quite a good shared understanding how to write code, how to format code, and we are sort of all on one page for that one. I mean, that's the other thing. That's a highly complex code base that essentially every Scala programmer is using. In that sense, it is quite stress tested quite a lot.
So would you say that the proposal of Lean Scala and the vision of Lean Scala do align, in your opinion, with what the industry needs?
Yes, I definitely think so, and I think we hopefully can be a trailblazer in the future. So I think Scala is quite unusual in that it became quite successful without any big corporate support. Most languages have a corporate sponsor that essentially pushes the language and provides a lot of resources for tooling, for documentation, for everything, for evangelization, these sort of things. And Scala has been doing with essentially, well, I mean, there's Virtus Lab, there's Lightband, there are companies that support it, but they are not like big enterprises that have unlimited pockets to support it. So Scala has to convince by just being the better language, because otherwise, if you have less support than others, so we can convince people to use it only by being a better language, and that's what I think we have been trying for since the start to do that, and we will continue. And I'm personally very excited about some of the new developments going on, from new type classes to capabilities and these sort of things, which are not yet there, but I'm very excited for the future, because I really think we are very close to be, by a very large margin, the go-to language for general purpose computing.
Okay. I wanted to go back a little bit to the concept, because the Lean Scala initiative, one of the most, I would say, significant goals of this proposal is to make the language more accessible to newcomers. Right? There's less to learn. Like as you mentioned before, if you try learning Scala today and you want to use it in any amateur professional setting, doesn't really matter. You first have to learn a language. That is
Mhm.
undebatable fact, right? You have to learn the basic language. But it's true that you mentioned what you mentioned before, that you have to learn something above the language, some way of expressing things. And the most prominent examples of this are effect systems today. You basically have to learn them too to be able to work with them, because they verify their own operation sets as functions on those data types. You have to have at least some understanding of how that works. So if Lean Scala is going to um, propose something that would simplify that, would you think that we should go back? You mentioned that we should update this document, but maybe we should go further than that. Maybe we should have some um, framework for teaching, framework for self-learning of Scala that would guide one newcomer, new Scala programmer, through the features that gently introduces all the new concepts and explain why and where when to use that. That would help address the problem that we see. That people don't really know when to use that, so they use it everywhere, and then huge rewrite
Yeah.
is bound to happen. So maybe that is something that we could collaborate on in the future and build something that would come out of this idea of grading Scala features, and have people have better understanding of what to use when, based on some reference material, which is currently, I don't think it does exist, because we had to find this
Actually,
blog post, right?
yeah, that actually, come to think of it, so I mean, I have these courses on Coursera, which are the first two, which are the basic language. Afterwards, it's essentially one thing on reactive and concurrent, and the other thing on Spark. But the first two, I think that is a canon where you could say that is what I believe is the common thing. So there we go. We start with purely functional. We have things like, well, of course, classes, objects, classes, functions. We have opaque types, extension methods. We have intersections and unions. We have givens and using clauses. We have some use of vars and mutation, and that's it. I think that's probably it. So we have a little bit of traits and things like that intro, which these things got a little bit shortchanged because the topic of the thing is principles of functional programming. So the object-oriented parts maybe need to be emphasized a bit more. The problem with the Coursera thing is it's a bit difficult to access. I mean, you can audit the course if you click through a chain of things, but it's not sort of easy to consume at a glance. So maybe it would be actually good to extract some of the material for that and make it sort of available for more random browsing, so random access browsing, these sort of things. But I think we have actually a set of features that work together and that are complete, in the sense that we can do a complete course with referring to just these features and nothing more than that. And I'm going to start and do a new edition of the course in 2 weeks when the semester starts again, for probably 450 students. Yeah.
That's good to hear. Okay, so I wanted to ask you about some of the existing features and features that seem to change. So you mentioned the new proposal for syntax of single type argument type classes. I wanted to ask you about the type classes themselves, because since there seemed to be an interest on your side in improving them, what is your opinion on the role the type classes will have in future of Scala?
So I mean, type classes are great. They address the shortcoming of object-oriented programming, where to extend a thing, you have to declare that in the extending class. So you can't come and say, well, I have an implementation for, let's say, a coder or decoder, and it's here. No, it would have to be essentially defined in the implementation of that. So you can't come from the outside and say, well, let me just connect two types together, an implementation type and a type class trait. And the other thing is, you need type classes to make these things conditional, and that happens a lot. So let's say the ordering is a typical example, that you say lists have an ordering only if the elements have an ordering, and you need a type class for that. And these cases just come up all the time, and the classical object-oriented class extension inheritance is just too inflexible to do these things. So we should embrace that more and use it for more features. And the and also take uh, the example of other languages that have done that successfully. So they're mostly, I'm thinking of Haskell, but I'm even more thinking of more modern languages like Rust and Swift. So in Rust, type classes are called traits, and in Swift, they're called protocols. And the two designs are actually quite similar. And they are pleasingly powerful because they combine type classes with what they call associative types, which Haskell does less. There are associative types in Haskell, but my understanding is they're not as much used in type classes. In Rust traits and in Swift protocols, it's the only thing you can do. You can't parameterize a type class. You have to use these things. And those map are an excellent fit in Scala because they're just member types. We had them forever, these sort of associated types for us. And it turns out that if you have this sort of revised view of type classes, a bit more like, let's say, in the Rust trait tradition, one can get much further than what we have now. And so I think that we can make the type class experience much smoother than it is now, with less pitfalls, and make the code much clearer that uses them. So that's my motivation for pushing the envelope with that. And it's basically, it consists of a bunch of small improvements, small features, one step after another. But I think we can get there. The big thing where sort of the end vision, everything together, is available under a language import called experimental.modularity. And that has already implemented as an experimental extension most of what we want to do.
Okay, it's good to hear. I do have a question that I wanted to ask at the end because it's one of the questions coming from our audience. I did ask our audience to prepare some questions beforehand, so I have some of them already ready. And this one actually, I think it fits the context. So one of the engineers asked, "What is the story for Scala Standard Library and Scala free migration of the standard library? Is it going to happen? When, if ever?"
Well, the thing is, if we migrate the standard library, at that moment we cut off the interop with Scala 2, which is a big ask. I mean, that will be a very, very drastic step, and I don't see it happening anytime soon. What I see happening, and hopefully soon, really soon now, and like in the coming weeks, is that we can finally unfreeze the standard library and add stuff to it. And then there could also be Scala 3 specific additions to it. So that's the hope. We have, with very hard work, we got to some degree that we can now mix a Scala 2 library with a Scala 3 Tasty. Tasty is the Scala 3 interchange format. So we can sort of put a Scala 3 mantle on the existing Scala 2 library. As long as things are bytecode compatible, we're good. But even with bytecode compatible things, we can do a lot. So for instance, we can now inject an inline method into a standard type like option, because that doesn't affect the bytecode. These methods are inlined, or we can inject annotations, and these annotations, for instance, we use that to actually implement capture checking for these things. So that's one thing where we can hopefully do little changes to the Scala 2 things that are Scala 3 specific, and in the future we can do additions. That's also really important. But for the time being, and I think, I don't know, I would say at least the coming 5 years, I believe there will be a common core between 2 and 3. Basically, I think we can drop that umbilical cord only when 2 is essentially goes away, which might not happen ever. We don't know.
Okay, I wanted to go back to the discussion that we had about Lean Scala, but Alex Nadelko is with us, and he did just ask about another thing that is very context relevant here, which is, in the context of simplifications, shouldn't we worry about having many ways of expressing the same thing? Recently, self-type versus higher content types, context bounds versus using, brackets versus indentation.
Yeah, I think that is a concern, and it's a typical migration concern, I would say. So we right now, because we came from somewhere that was Scala 2 and we're going somewhere else, we allow all things and new things. For instance, braces versus indentation. I believe that what we should do for Lean Scala specifically is to say, well, you should favor indentation, period. That doesn't be, we don't need to be inclusive for that, so we can just say what we think is best practice. The other thing, it depends. So context versus using, no, not really. If one thing is clearly a simplification, notational simplification that maps into the other thing, then for me that's not two ways to do the same thing. It's a higher level way and a lower level way, and that we essentially every language needs. And if you don't do that, then you say, well, you're happy to just stay on the lower level way everywhere. And I believe for context bounds are useful enough, definitely useful enough that we want them, want to keep them. They have been very useful in the past, and they will be more useful in the future. What was the other thing? I forgot the third.
Brackets versus indentation, context bounds versus using, and self types versus higher kinded types. Those are the examples Alex provided.
Yeah, self types is one of the things that I believe. In retrospect, I think we should probably move away from them, or at least find better notation for them, because I have the impression self-types are a very exotic feature that is not super readable. So if you see this and you don't know it's a self-type, you would have no idea what this is. This thing, this funny thing that ends in an arrow at the beginning of a class. It has semantically, it has a very clear meaning because it gives you the type of this, and it turns out that, as always, it's better to be flexible to give you freedom what the type of this should be. Because if you just say it's the enclosing class, that's often not actually the right thing. But we should find better syntax. So one way to maybe do it would be to just have sort of a pseudo val this colon type, which says, well, this has this type. That would make it clear. Well, I give this a type, whereas the self-type syntax is a bit too obscure, I think. I don't think self-types and higher kind of types are necessarily the same alternative ways to do the same thing. They are sort of building blocks for quite different things.
I would say I agree. But yeah, the self-type annotations with indentation syntax are kind of surprising. I had this exact problem not long ago, to be honest. That I've seen the trait colon and then enter, new line, and then there's the self and an arrow and wait, what?
Yeah, exactly.
It is confusing. It was a bit easier to think about it when you had brackets. I don't know.
It was added in the very early days of Scala for. I think it was actually Phil Wadler that made me do it. He's responsible for a lot of the stuff in early Scala, including XML literals. He said, because I said, well, we have a formalization of this thing, an early formalization for the concepts in Scala, and it has essentially an explicit type for self. So you can, for this, you can give this a type. It's not the class. And he said, well, if it's in the calculus, you need to put it in the language. And I followed that advice, and that's what we did. And I think it's still good that we did it because it is necessary. It is a core concept of the underlying foundations, but the way we did it is less than ideal. Yeah.
Okay, I think we can get back to the original thread, but the actual question that I have as next is actually still involved with that. So there was a second facet to the discussion about new syntax for type classes, right? And that was the general concern that you are basically changing the language, and it's just going to happen without any discussion. So it did go through the discussion, so everything seems to be fine with that. But there was a new source of concern that happened last few days, basically, just the the news that Scala 3.7 is going to introduce changes to given resolution prioritization, right? So I wanted to ask about how does that look from your perspective, like language designer, lead of the team that works on the
Mm.
compiler. What I'm missing the word. Well, what steps did you take to make sure that breakage, if there is any, is reduced to absolute minimum?
Mhm.
How are you making sure that this change does not disrupt end users of the language?
Okay, maybe I can sort of say how I came to that. So I was challenged by a postdoc, Dimi Racaudon, who has close connections to Swift, to actually do some of the typical Swift type class patterns, and I couldn't. It immediately got ambiguous, and there were a couple of other things which are different things to address, but this was sort of a glaring hole. And I looked at it. So the typical example was you have a functor and two subclasses, monad and applicative, and then and you have, let's say, you have instances for each of these three. So you have givens for each of these three, and then you want a given for a functor. So you have using functor, and the compiler will say, "Oh, I have a functor, but I have two things that are better, monad or applicative. I can't decide between the two. So I give you an ambiguity error if all you have asked for is a functor. So, and it has a type class for functor. So it makes no sense, right? So, and these triangles that happen everywhere and all the time. And if you go like to actually code bases like type level stack or that do these things, they solve that all with very cumbersome explicit prioritization using essentially a bunch of classes that extend from each other to sort of fix these things. So it was painful because the language didn't do the right thing. The language worked against you. And so the question is, why didn't we detect that earlier? I mean, it's been with us forever. And why didn't we detect that as earlier? And there, I think it's a problem culturally in Scala that a lot of this stuff came from Haskell, and Haskell doesn't give the right guidance. So Haskell specifically says, well, everything has to be globally coherent, right? So, and that's what people were asking for all the time because they were unhappy with the way essentially actual type classes were resolved in Scala. I said, can't we have coherence? Can't we have coherence? Now we said, no, we can't have coherence. It's not modular. It's not in Scala way at all. But because of this fruitless battle, the obvious way to say, well, you're doing something wrong with prioritization fell completely through the cracks. Nobody observed that. Nobody noted that until very recently. So that's the reason why. So then I said, oh my God, we did it wrong for so long. Can we do it right? Is there a way to do it right? And we have the local community build, which is about 30 projects, including Shapeless 3, type level, a bunch of projects, quite a lot. So I tried it out with just changed the priority with them, and it turned out everything compiled. Everything worked, tests worked. The only thing is there was something that was obviously a typo in Shapeless 3 that got detected by the change. So I said, wow, this is amazing. We actually very few things change. So maybe we can actually pull it off, but it's still a very risky thing to do, of course. So then we went to the open community build, which is 1,500 projects, and tried it out there. And there, I think it's roughly a dozen projects broke, which caused us enough concern to say we will actually not ship that in 3.6, the next version after 3.5. We'll wait one version so that we have a longer migration period. And we also sunk a lot of effort. I think I worked more than a month on that, almost exclusively, in tooling to actually notify you of the change at compile time. So if a given resolution change, if it changes in the future, you will get told that is, and then probably you should inspect the code and see whether that's okay. In most cases, it's okay because you have different front ends that in the end call the same method, let's say, but sometimes it's not okay, and at least you're being told. So it is a super. I think it is a thing we must do if we want to make progress on type classes, because otherwise, I'm sorry, but it's just never going to happen. It's never going to be a credible type class system in Scala. And it's a thing that's really scary to do, but I think we can pull it off with the tooling.
I think the biggest concern is that this change is going to change the behavior of fully compiling projects. So the compilation won't result with an error. The compiler will just compile it in a different way.
Mhm.
So is
Yeah,
this something that is a risk? Can this happen with this change?
exactly. Yes, yes, that is the big risk, and that's why the compiler will tell you if there is a possibility of a runtime change. So you do get a warning that there is a possibility of a runtime change, but then of course it's on you to figure out why that is, and
Oh, so
that was
there's a compiler warning about the change
the
happening in this
compiler
case.
warning about the change. Yeah.
Oh, okay. Well, that seems reasonable. I'm just wondering how this will percolate through the ecosystem where we have this tree of libraries that each depends on another. But it
Yeah.
is it
So
is detectable at least with fatal
yeah.
warnings.
So according to our tests, the damage is surprisingly small. And I believe that is because things really don't work out really very well. A lot of the more heavy users of implicits do their own prioritization, which we won't touch. Which, I mean, if a user does a prioritization by a class hierarchy, that will stay the same, of course. So those things. So that's maybe an explanation why the fallout has been quite reasonable from what we can see.
Okay. I wanted to get back to the original topic of discussion, which is Lean Scala, and get back to the features. So Scala is quite prominent and quite known for type level programming, and it's quite common hobby for Scala programmers to occupy themselves with type level puzzles. I wanted to ask you, what is your opinion on type level programming? And when thinking about going into solving another interesting puzzler on the type level, where do you think, if there is such a um, threshold,
Mhm.
where is the threshold, if there is any, where one should decide not to solve type level puzzles and just give up on the type level? I mean,
Oh,
type system. Sorry.
it's very hard to give general advice on that. I mean, there are amazing things that are being done with type level, like Jason Eiter does essentially JSON pickler unpickler completely on the type level, and the result is it's blindingly fast. It's the fastest JSON decoder that he can get. So this is amazing. The and yeah, so it's difficult. On the other hand, yeah, it has a cost, because it has a cost in understanding the code base. If you don't, I mean, types are there for documentation. If your types get computed, which is the definition of what type level programming is, that documentation is gone. It's almost as bad as dynamically typed code. You don't have the type. So in here, you have the type that is a result of a complex computation that you won't have insight on typically if you're not an expert or the author of that library. So type level programming creates magic, and sometimes that magic is great. Like when it comes to like this JSON ITER thing, or for instance, when it comes to supporting something then like name tuples, which require a lot of type level programming on the tuple side. Um, but you have to know what you're doing, basically, and the benefits have to justify the cost, because the cost is real. So I believe the important thing is first to realize that there is a trade-off. So there's some people who say, well, if it can catch an error that there could happen at runtime, even if the error is not very common, then any amount of effort with type level programming is justified, because I have caught something at compile time that otherwise would have manifested itself at runtime, and compile time is always cheaper at runtime. I don't believe in that, frankly. I think if you can just as well do something with a simple test or two, then often that is the simpler solution than investing a lot in type level effort. I have one episode here, anecdote to tell. in the compiler itself. So the compiler, it's a standard compiler. It builds a tree that represents your program, an abstract syntax tree, and then it has a bunch of phases that transform the tree. And the tree gets changed by the transform, and some kinds of nodes get eliminated. For instance, there's a pattern matching transform. After the pattern matching transform, all nodes of the tree that represent patterns shouldn't be there anymore because they should have been eliminated by the pattern matcher. Now, it's an interesting academic problem, and many papers were published about that, how to do that so that every phase can have a tree that exactly represents only the kinds of nodes that are available in that phase and not the others that have been eliminated. So it's that you can create really amazing type level frameworks, but they're all at complexity. So we decided, no, we don't do that. We have a single kind of tree, and we just have essentially a test, a verification that can optionally walk through the tree at a phase and decide what kind of nodes are still legal, or which, and flag the others which are not legal. And that has worked really great for us, because it happened from time to time that, yes, a phase would recreate a node that was no longer legal, so the tests would catch that. But it was quite rare. It's not a common error to make, and we didn't really weigh down all the treatment of the syntax tree, which is, after all, the central data structure of the compiler, so you want to keep it simple. So that's an example where I would say testing trumped going from 99% to 100% precision by throwing a lot of extra effort into the type level thing. Or otherwise said, there's always a law of diminishing returns, right? So the more perfect you want to get, the harder it gets.
I understand. I'm just smiling because Anton Spirit, who is also with us, just asked about exactly this 99% point thing, because he asks, what sort of work is required to ensure that composing advanced Scala features doesn't lead to horrific error messages with internal type elaborations being dumped verbatim into the error messages?
Yeah, it's actually very, very hard to do that. Sometimes impossible, but always very hard. So you have to do it punctually to say, well, is there a class of errors which could be improved, and then let's work really hard on that. So for instance, the most glaring thing that we fixed in Scala 3, and which made a huge difference, is I think is the import suggestions for implicits. That was missing in Scala 2, still is missing. So if you miss an import for some implicits, you're left completely alone. You have no idea why this thing goes wrong. Whereas now you actually get a suggestion and said, well, maybe you meant to import it from here or something like that. And that required a lot of engineering to get there. And I know that some libraries like Doobie also have a lot of engineerings to hide implicit failures and things like that, and make really understandable error messages. But it requires a lot of work.
That's true. I do recall that we had a conversation with, I'm not sure whether this was internal conversation in Virtus Lab or whether this was a conversation with some other community members. Can't recall, but it was a feature request. But I will open a feature request to the compiler instead of swamping you today with that. Okay, so you mentioned cost, and that is something that I also wanted to touch upon, because one of the common complaints about Scala always was, and I think it is to some degree till this day, it's the compile times. So I wanted to ask you, what do you think about Lean Scala and interaction between Lean Scala and compile times? And also, in the same vein as we're talking about language features, I wanted to ask you if you and your team have any particular observations about singular features that have the biggest impact on the compile times, or interactions between some features that cause the biggest amount of compile time problems. After you.
Mm-hmm. So yeah, compile times vary a lot in Scala depending on essentially what features to use. I can maybe just say our internal one. So if we do a clean build of our 100,000 line code base, it takes less than a minute, 40 seconds or something like that. So that translates to 2,500 lines per second, something like that, which is not the fastest, but reasonable, I would say. So but there are also a lot of code bases that have considerably less, that are compiling much slower. Well, first I should say there's the problem inherent in being run on the JVM is if you start the compiler cold, then hello world takes, I don't know, 5 to 10 seconds just to start up the whole thing, to scan the class path, to start the compiler. But the Scala CLI, typically you run these things on a server, so that's just a one-time startup, and then it should be much faster. But that out of the way, I mean, we still have, for large code bases, we have a problem even after VM warm-up with essentially features that just cost a lot. And a feature costs a lot, generally, if it either generates a lot of code internally or it does a lot of search. So that's the two things. So features that can generate a lot of code are complex implicits, in particular recursive implicits, so that construct implicit evidence that follows the shape of your data or things like that. Those often work well if you have like 10 fields, and they work not at all if you have like 200 fields, things like that. Um, and implicits can also cost a lot of search overhead. Massive overloading costs, because you have to essentially compare all the alternatives one against each other. So I've seen code bases like in Scala test, you often have 20 or more overloaded variants of the same thing. That costs compiling. Match types cost for the same reason as implicits. Like if they're recursive, then there's a lot of computations until you have the result. Those are sort of things that are potential slowdowns. And then, of course, macros can do everything, and macros and inlining can inline arbitrary amounts of code, so that can also slow down your program, of course. If you don't do a lot of that, so in compiler we do quite a bit of inlining, but only of really small things, so it's not an issue. And we do have basically implicits everywhere, but it's super simple. It's just a simple context, so which you always find immediately, and that's why we get quite reasonable compilation speed. That we don't do very little of the complex stuff.
Okay. Well, it seems that having a general direction in avoiding very gnarly and advanced features in your code base should lead to better compile times too. I do have my own observation, which might be of interest to you, and I probably share the same observation with Oliver Melois, who maintains Smithy4S, because both BSOM, so the infrastructure management for Scala, so the Pulumi Scala implementation basically, and Smithy4S, they do a lot of code generation, and that code has to be compiled in. So interesting bit is that I did cut compilation time of, I think it was an Azure package, in half, from 4 hours to 1 hour 55 minutes, I think, just by managing warnings. So we had the generated code generated a lot of warnings. Those warnings seem to fill the heap very quickly, and then we get garbage collector thrashing, and everything grinds down to halt basically. So cutting the code, rather refactoring the code that yielded those warnings, basically cut the compilation time in half. So
amazing.
Yeah, there is a lot to think about other things that you wouldn't expect to generate such problems with.
Yeah, of course, that's the other thing.
Accumulation.
So many things can behave in so many non-standard ways that you wouldn't expect. That's true. It's a very complex problem.
Okay, I do have one more question, and we will be slowly getting to the finishing line. So after this question, we do have some questions from our live users. But this question is also something that surfaced before the podcast, and it's actually from one of the engineers at Virtus Lab. And the question is, what do you think of exceptions and their role in Lean Scala? Um, and my note is that it's a common conviction among Scala developers that exceptions are basically pure evil because you have a signature that lies. You have a signature that says, "Oh, this will return an int," and it doesn't. It just throws an exception. So, what do you think about exceptions in the area of Lean Scala? Is there a way that we can tame them, make them safe, and is it possible, in your opinion, to make them safe in the context of one of the most commonly occurring things in Scala code bases, which is easy concurrency?
For easy concurrency, I have the impression that we do bundle exceptions as values in try, right, when we return from futures or things like that, which I think is the appropriate thing to do. In general, exceptions are yeah, I mean, there's been such a long debate about them, and no, not really a good resolution. So, because exceptions come in all forms. So one exception could be, let's say, an assertion violation or a bounds error, or another kind of exception could be an out of memory, or the. So there are exceptions that where it really usually doesn't make sense to reify those things in a value, where you want to shut down a part of the program. So I think every language has some form of panic that shuts down the program. There's no mainstream programming language known that is 100% total, where you say it will always end without a panic or something like that. And there is code that wants to catch these conditions because there is code that wants to play operating system. Let's say if you are Katz effect yourself or Zio yourself or Akka, at some point you want to catch the errors that were thrown in the user code and do something with them, log them or process them. And at some point, maybe you also want to restart a computation to say, well, this thing didn't work, let's try again. So there are things, so that these are sort of things that there are rare events, but when they happen, you want to essentially see a stack trace and you want to be able to handle them. And for me, exceptions are, my understanding of exceptions has also evolved quite a bit. So for me, that's sort of the core of them, where I say they're still appropriate and we can't do without them. Then the other question is, well, if you have a more common thing like this channel was closed or something like that, should we model that as an exception, or should we, or let's say this form doesn't validate or whatever, or should that be a value? And there, again, I think it should clearly be a value, definitely. Right now in Scala, we have the problem that these values don't compose very well because monads don't compose very well. So essentially, well, first, without monads, it's hopeless. You have to constantly ask, well, is it the error case? Is it the normal case? So then you have happy path programming, which means monads. You just go straight through and take the success path everywhere. And essentially, the monad ensures that the error path will essentially error out early of this thing. And that's also okay. But it starts being a problem when you mix these things with other monads, as we all know, because monads, well, composition of monad computation, you have to learn about traverse very quickly. It's not pretty. So the what I would like to see is something like what Rust does with the question marks, and I think we basically have that. We can write a library like that with boundary break as the basis, and that is a value-based view of errors. I mean, result of either is exactly that, but it is a way which is more flexible in its usage, and it doesn't require you to cram everything into a monad just because you want this basic error handling. So for me, that's sort of my understanding, that we want that. Originally, I thought when we started with capabilities and capture checking, we thought exceptions is sort of the prime case. So we said how to make exception handling safer. But now I have the impression that exceptions are clunky in many other dimensions, and it's probably not worth bothering dressing them up with like declared exceptions and things like that. It's also a cautionary tale that only Java tried that, and I believe Java's way to do that is generally not liked very much. I believe with what we do with capture checking, we actually have better tooling, better ways to deal with it, that we can solve some of the problems, but I don't think we can solve all of the problems. So for now, I would say I would actually de-emphasize exceptions and let them be sort of the things that you really don't want to handle and that could terminate your program unless somebody else out there cares enough to resuscitate you or something like that. Yeah, but locally it should be basically a termination condition to say, okay, I'm done.
Yeah, that is true. My experience with them is also very similar. I came to Scala from Java, which uses exceptions for the general flow
Yeah,
control. And one of the earliest experiences that I had with Scala was that, oh, okay, so if I throw in a feature, it's something completely different. And if I throw during construction of the feature, it's also something completely different. It
yeah,
can completely break the feature
yeah,
system. So this is basically the context in which I was asking about whether
yeah.
we can make exceptions safe in area of concurrence, because the common problem is that you can, well, let's talk about boundary break, which is a new construct in Scala 3, which basically operates as an exception with evidence, implicit evidence that you can throw this. It is safe to throw this
Right,
because there is
exactly.
somebody waiting for you
Yeah,
to catch you. But the problem is that if the piece of code that does execute the code that will throw the safe exception, um, it goes away on a different thread. It kills the thread because, well, it's asynchronous. It's no longer happening in the same synchronous block of code. So what can we do about this actually?
oh, we can wrap it in a try, definitely. We should never kill the thread. Or the thread should just terminate when it terminates. But we should wrap it in a try and say, if this thing happens in a different thread, then if there's an exception coming out, it will be reified in the value. And when you await for the value, then it will essentially be reconstituted in your thread. So I think for that try is actually the right
I mean,
abstraction.
the problem is with boundary break, right? So if we have a boundary and then
Mhm.
we fork
Yeah.
a computation, should we really bother with using boundary break in the first place?
Yeah, I think so, because there's a long-standing debate where many people disagreed with me, but I think these aborts in boundary breaks should be treated like exceptions, so they should be caught in a try like all the others, and that's what makes future safe. That's what makes it safe to say, well, if there's an exception that terminated that future, you will find out about it when you await that future.
To be
So
perfectly honest, I'm confused because I kind of hope to hear about capture checking capabilities in this
Okay.
context.
There's another thing that you say. Some of the transforms just don't make sense. So, for instance, if you look at let's say we have an async monad and we have an error monad, and we want to sort of swap these things around. So we can basically do it only in one way. If we have an async that returns an error, we can't really return that into an error of async, because for an error we'd have to know beforehand whether it's an error or it's bad, and with the async we find out only afterwards. And it turns out that so that's sort of one of the examples where people say, well, essentially the reason monads don't compose is because of situations like that, where it simply does not make sense to compose those two monads. It would be semantically lead you into semantically troublesome things. And for capabilities, it turns out you can always compose these things, including do this. You would maybe be surprised what comes out, but to essentially rule out transforms like this that make no sense semantically, capture checking will essentially have your back. Capture checking will tell you whether something makes sense or not. So in that sense, it's a necessary thing against leaking resources in frameworks like that. But generally, I believe the fundamental interaction between boundary break and exceptions is it is a form of exception. So I'm also saying exceptions. It's not bad. I'm just sort of turned against fine-grained exceptions that you declare in your code. I think that's self-defeating in the end. So exceptions as sort of panics or just let me get out of here is has a role. The other observation is exceptions are actually the less problematic, the more functional your code is, which is kind of a paradox. So if your code is functional, then you can at any point say, well, okay, so let's just essentially signal a thing to a level higher up, and I don't need to worry about cleanup of resources and cleanup of side effects and all these things that I have to worry in the normal case. So one example again in the compiler is that so we have a thing where in the compiler we have a very deep call tree, of course, and at some obscure corners we detect an error. But in these obscure corners we don't have the means to actually report the error, and it might anyway in a situation like where we would backtrack. So maybe that's just one speculative thing, and we backtrack. So we shouldn't issue an error at this point. So a typical case is a cyclic reference. We discover cyclic reference, and that's something that at that point where it could happen in many points, but at that point we don't really know how to handle it because we don't know where we are in the source. To report an error, we have to know essentially the current position in the source, where we should report this error and the context. So what we do in that case is we throw an exception, and the compiler then, for each line of code or each node of the tree, it actually catches that exception and says, well, if there's one error of these things, then essentially just report the error and continue. So that way we have a position and we can do that. We can do this only because the compiler is really very, very functional. If the compiler had global side effects, this would be absolutely awful because the exception would interact with a lot of things. But because of the architecture that is actually very functional, we can do this. And in that case, even though it's a scary use of exceptions, I think it was the right use of exceptions at this point. So I'm not strictly against exceptions. I just say don't use them for things that can be produced with normal error values. And here the alternative would have been well, basically deep down we discover we have a cyclic reference exception or cyclic reference error. We'd have to thread it through everywhere, and that would actually pollute our whole code base. So that's, of course, in those cases you say no, but you have to really restrict that to very, very rare cases, and the more functional you are, the better for these things.
Yeah, I also agree. It kind of goes with the philosophy of functional core and imperative shell, right? So
yeah, in some sense, yeah.
Okay. We do have some questions from the audience. We went through, I think, 2 of them, but there's more. So somebody called Hussein asks, what features or ideas that isn't or aren't in Scala? I think the idea was that what features or ideas are interesting but aren't in Scala, and if there is a plan to add them in the future. I think that's what the person meant.
Okay. So the main thing we are working on is scalabilities and capture tracking, and that is still in the research phase, but we're making good progress, I think. So that's something that if that matures, I want to add that in the future. So that would be essentially adding colloquially a borrow checker or something like that to Scala to check not just exceptions, but also side effects and I/O and all sorts of effects, async, these sort of things. And I think the beginnings are ready to ship. We have just managed to compile the standard library under this mode, and that will be the basis for lots of other things. And the thing that still needs to be fleshed out is how to deal with mutable data structures and variables, and that will be the big prize to say. But if we really can have a way to have functions coexist with mutable data, and that you know what's the difference. So for instance, a simple thing is you get a hash map, and but often you should get it, and you should actually not mutate it. You should just consult it, right? And in other places, you get a hash map, and maybe you should be allowed to mutate it. That there's no difference in the type system is really a pity right now. That's a thing that's an aspect that you definitely want to track, whether it's something you should have the right to mutate something or not. And conversely, to say, well, if you don't have the right to mutate anything, then you're forcibly a pure function, because that's the only thing that it can be. So I think these things are very appropriate for a language like Scala, because Scala has the genes of Scala is really to be a mostly functional language, to put emphasis on functional programming without being a pure functional language. So that's what we do not want. But then, of course, the open question is, well, how do we manage the boundary between purely functional and not? And right now, the answer is, well, we manage it by advice. Don't use too many effects. Don't use too global effects. We manage it by convention, sometimes documentation. But it would be great if we could manage it by types instead.
Okay. We do have a question from Nico Soar. How important it is for Scala to be popular? Is this measured somehow?
Well, I think it's important to have a sustainable ecosystem that is popular enough that investment in tooling pays off, or is being made because there's enough return on the investment. If you don't have that, if you're too small for that, then essentially even you could have the greatest language in the world. If the tooling sucks, it's not usable anyway. So I think that's sort of very important threshold, and I think the bar has gone up. When I look at when Scala started, fortunately the bar wasn't that high. So lots of languages didn't have an IDE, for instance. It was okay to use just an editor and these things. So tooling was less of a problem. But I think now developers know that they can do much better, and consequently the bar has gone up, and also the amount of investment you need has gone up. So that's important. As for the rest, as for whether we are number 15 or number 1 or 2 or 5, I really don't care too much, because I think that for me it's much more important to do a better language than to invest my time in increasing the popularity of the language. And in fact, it's sort of the only means I have, and that's why I'm exploiting it, to say, well, the only means Scala can become more popular is if it's a better language. So that's what we're working on.
Okay. And I think we have last question from Francois. For the big language survey, Scala, it looks like the community of Scala programmers is becoming older, with a pyramid of years of Scala use looking like one of Western country. Oh, demographics. Opposite
Right.
of what it should look like for renewing.
Yes.
It's normal for an older lung to have some devs using it for extensive periods of time, but do you have insight about why so few new developers choose Scala? Could it only be disponibility bias? Oh, I don't understand the last phrase. Well, the question is basically why new developers aren't choosing Scala.
That's indeed a big question, and one which troubles me. So I think we should try to turn this around. I think we have the right language for young developers, and it's part of it is, of course, that as code bases mature, Scala, the language is identified more and more with like enterprise programming because we have enterprises that care about it and who are vocal. So it's that, and that's often then not the cool language for like newcomers to come into. Um, the other thing could be that the JVM as a platform itself has become pretty enterprisey. So it's maybe a hurdle. Maybe young kids nowadays start with Python or something else, and for them it would be a big jump to go there. But I'm just speculating. I don't really know, and but I can just say I do care deeply about that, because we had some really brilliant kids when Scala was young that picked up Scala, and I do hope that we can get back to that and revive that.
Mm. Francois did clarify the last part. So perhaps we don't have the correct tool to measure the quantity of new developers. And if so, do you have an insight about it? I would say we don't really
We
have a tool like that.
No,
And I say that with the knowledge of the endeavors that happen at Virtus Lab, because this is also our concern. And I mentioned that at the beginning of the podcast that one of the crucial points that we had that led us to the understanding that Scala is pushing itself by the use cases it's being used into being a niche language that is deployed to solve some very complex problems, was that, well, it isn't very easy to use Scala to do easy things. You can
yeah,
solve very hard things with Scala, but it's not trivial, at least not as with the competition with the languages that we compete with. It's not easy to do something very easy.
correct. Yeah,
But about the tool to measure that, that's a hard one, as that's a sociological question, to be honest.
yeah, it's correct. And so yeah, that's definitely one thing to that the community, the ecosystem has to address, to say there needs then we need more accessible libraries, definitely, and more accessible stacks for doing the easy stuff. That's definitely true. It's a bit of yeah. I think a bit went into over engineering. So, for instance, SBT is ridiculed for being called simple build tool, or it was called a simple build tool. SBT was a simple build tool at some time. That was in the 0.7 version, and then it got completely redesigned. It didn't resemble so 0.7 was a bit like I would say what Mill is today, simpler, but because it didn't do as much, but sort of same philosophy. And then it got completely redesigned in 0.9, and the authors thought, well, this is fantastic. It's so more powerful now. It is more powerful, but it's not simple. So this cycle has been taking place several times in Scala land, and not always for the better. Another thing which was started out as super simple, and now it's maybe okay, but definitely not super simple, is Play. Play started out as sort of the super refreshing, fantastically simple framework, and now it's one of these big frameworks which does its job, but simple it is not. No.
Yeah, that is true. Okay. Oh, we do have another question.
Okay.
Okay, but we really do have to finish soon. Okay. So, how do we avoid complexity to creep up anyway? For example, in Java, Spring is not simpler than our functional libraries. Scala CLI is nice because it lowers barrier to entry, but it is not applicable everywhere. Well, the question is, how do we avoid complexity to creep up anyway?
Mm. Yeah, I wish I had a good answer. I think the point is um, to to develop a sensitivity for complexity, and to realize that abstraction has a price. So, I mean, we have two things going for us in Scala land that are fundamentally good things. One is being functional, and the other being statically typed. But there's a law of diminishing returns for both of them. So pushing either too far tends to complexify things. And we have a tradition of essentially going maybe one step too far in these things often. So essentially take a step back and really have a critical view of what you're doing, and whether there's a simple simpler scheme, even if it doesn't catch this or that type error, and it relegates it to runtime. From my perspective as a language designer, we're working really very intensively of hopefully having language constructs that support this better in the future, like the capability checking and these sort of things. But that's in the future. But otherwise, I think right now, I think it's probably a good thing to trade simplicity for perfection in terms of being purely functional and 100% type safe. That's the only thing the only knob we have right now, I think.
Okay, so basically boils down to restraint, which
Yeah,
is always troublesome.
always difficult, of course. Yeah.
Okay, I think that would be all of it. Another person just remarked that it's very much about the zeitgeist as well. Go is just Java 6 without the JVM, but it's still very popular because it is simple, and now it has gotten generics and iterators, which is true.
Mm-hmm.
I've seen the implementations;
Yep.
they do leave a lot to be desired
Yeah.
themselves. So they are also, drifting towards complexity, as is everything. Okay, I
And
think
even in the brackets club, in the club of the few languages that use brackets for generics instead of using angle brackets. So welcome to the club, we can say, from Scala.
yes. Okay, thank you, Martin, for
Thank
being a
you.
guest today, and thank you, all the members of our wonderful audience. See you in the next episode. Cheers.